So if these reactions don't go to completion by 100%, but rather all four things are present, we can't use stoichiometry anymore. When I had 100% arrow, we were allowed to just use stoichiometry because for every 2 blocks, if I formed 3 Ds, I could just use my stoichiometry relationship because all of those 2 blocks would make my 3 Ds. And so I could just do stoich. But if I don't have 100% arrow, but rather I have a little arrow, like let's say even 1%, then only 1% of those 2As are going to make my 3Ds. Only 1% of them. So I can't just go times 3 divided by 2, but rather I have to like do something different. Take 1% of times 3 divided by 2. But we often aren't given percents either. So what we're given is equilibrium values. So when we can't do stoichiometry because we have something in equilibrium, we have to use this thing called an equilibrium expression or equilibrium law. So it looks like this. If I have A and B making C and D, and these are my balance coefficients, like 2 and 3, for example, then my equilibrium expression, so K talks about the equilibrium constant. The C just says that I'm going to use concentrations for this. And or EQ, meaning I'm using the equilibrium concentrations for this. These are interchangeable, okay? And this is a little bit like where we had, we had delta HC for combustion and delta HD for decomposition. And then we had delta H reaction for like any reaction. Kind of the same thing. This is like for concentrations, any concentrations. This is equilibrium, any equilibrium. Okay, anyway, so what you're going to get is your products, the concentration. It has to be concentration. So if they give you mole and volume, you got to figure out concentration. So I'm going to take my concentration of the products and multiply them by each other. And they're to the power of the coefficient. So C to the power of its coefficient times D to the power of its coefficient, all divided by, and I get this ratio happening, this quotient, A to the power of its coefficient times B to the power of its coefficient. So here's some examples for you. So in a homogeneous mixture, these are pretty straightforward. So homogeneous meaning the same, all the states are the same, gas, gas, gas. Okay, if all the states are the same, I include them all in here. So products over reactants to their coefficient. So here I have the product of HI to the power of 2 divided by H2 times I2 to the power of 1. So this is its equilibrium expression. Okay, the equilibrium expression for the reverse reaction, the decomposition, so here's HI decomposing into these two, is, well, products over reactant squared. And you can see that they are reciprocals of each other. So the reverse equals 1 over the forward reaction. That's the thing you have to remember here. So this is very different than delta H. With delta H, flippy, flippy, switchy, switchy, right? If I flip the reaction, I switch the sign. There is no sign here. K values are always positive. So it's flippy, 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 flippy. So if I flip the reaction, I have to take the reciprocal of this ratio because it's now products over reactants, products over reactants. Okay, so it's super important to remember. It's not switch the sign, but it's rather flip the quotient. Okay, so homogeneous reactions are pretty good. You just go products or reactants. Good. Heterogeneous are a little bit different. So hetero means different. So if I have different states in my equilibrium, for example here, I don't include them all. I only include gas and aqueous. So anything that's solid or anything that's liquid doesn't get included. So that's different because here they're all gas, I include them all. Or even if they were all solids, not that this would happen anyway, that hurts me to put solids. I'm going to put liquid because that's a little bit more reasonable. Liquid, 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 I would still put them all in. So homo, all the same, put them all in. But as soon as they're different, some of them don't get put in. So only the gases and aqueuses get put in. So this is solid, aqueous, aqueous, solid. So I only include my gas and my aqueous. So I'm not going to include the solid. I'm not going to include the solid. And so here I have the only aqueous product over the only aqueous reactant squared. And this is the K value for this one. Let's do one more heterogeneous. So here I have a solution. So barium sulfate is only very slightly soluble. So a tiny bit will dissolve. In fact, why don't we put some weird arrows in here? A tiny bit dissolves, but most of it stays as it's solid. And so the Kc concentrations, or Ksp for solubility, I don't know why it's not a B, but it's not. Solubility, anyway. So Sp, Ksp would be the two ions, because those are aqueous. I didn't even put their states in. Aqueous and aqueous over effectively 1, because I'm not going to include the solid, right? Heterogeneous, only aqueous and gas. So those two are included, but the compound is not. Okay, so that's how you set up expressions.